This time tangent has a value of negative 0.8. Well, tangent is positive in the first quadrant, negative in the fourth, with respect to our inverse tangent function between negative pi over 2 and pi over 2. You have to remember that. So let's say it's about here somewhere, and that's where our negative 8 is. And so the calculator is going to give me a negative answer. Small problem. This wants a positive answer. So when we get to that, we have to keep that in mind. So second tangent of negative 8, remember use the negative sign, not the subtraction, enter, and you see it gives me a negative angle, negative 1.446. That goes down into the fourth quadrant. So negative 1.446. Well, we also know that in terms of another angle in the second quadrant will also give me a negative tangent value. So let's see how we can figure this out. From this rotation, can't I go and add pi? So I take second pi plus the angle I just found. So second answer, and enter. And so this angle in the second quadrant is 1.695. To get the next angle in the third quadrant, I can add pi again, but wait a second. Yeah, let's do that. So I can do second pi plus, and the most recent answer is this 1.695. So just add second answer, enter, and this other answer is 4.837. The hard part about radians is the angles and values are both crazy decimals. And so you have to keep track of which is an angle and which is the value. Negative 8 is the value. 1.695 is the angle. Okay? And negative 1.446 is also another angle that went down into the fourth quadrant. So these are all angles. The only value in this problem is the negative 8. Here's what they want us to do for C. Do y equals and y sub 1. If you have anything there, just clear it. And do tangent of x. Enter that. And then in y sub 2, let's do a negative 8. Enter. To set our window so that x is between negative 1 and 7, we go to second just window, and make sure that the x minimum is negative 1, enter, and the x max is 7, enter. And then let's just have the y min be negative 10 and the y max be positive 10, like it usually is. For some reason mine was changed, probably for some other problem. So now if I graph, notice I have a few places where the red line, negative 8, hits the blue graph, which is the tangent graph. And let's go back left. So I'm going to go to Window, and I'm going to have my, well, they wanted the x minimum to be negative 1, so I'll leave it. So go back to our graph. Let's find this point of intersection right here. So we'll go to second, calc. Choice 5 is intersect. The first curve is the blue curve, the tangent curve, so just press enter. The second curve is the red line, where y equals -8. Press enter. And then guess, just move the cursor back to the left so it's kind of close to that point of intersection. Press enter a third time, and 1.695. Let's see. Is that what I had a moment ago? Yep, look at that. 1.695. So for my general solution, I can take that 1.695, and a moment ago, let's go back, we saw that in our picture. Once I have that first angle, I can go pi and pi and pi for all the angles in the second and fourth quadrant. So plus pi k, remember pi is the period for tangent, k is an element of the set of integers. So over here is our Ferris wheel. 20 meters in diameter. So from here to here is 20. Boarded from a platform that is 2 meters above the ground. So here's the ground. Here's where we get on the Ferris wheel, and here it's 2 meters. We're going to complete one revolution in 6 minutes. And they give us the equation. So we can kind of figure out some things. If we load at the bottom of the Ferris wheel, that's here, and then the Ferris wheel runs. So time is going this way. This is time. Ferris wheel is going to go up and then back down, and that's a negative cosine graph, an upside down cosine graph. If it starts at 2 and it's 20 meters wide, it's going to go up to 22, and midway is 12. It's 10 this way and 10 this way, and that's our amplitude, like we learned before. In our middle used to be the x-axis, but we've moved it up 12. We could have come up with this equation without them giving it to us. And then one more thing. What's period? Well, period is 2 pi over b. b is pi over 3. So that's 2 pi times the reciprocal, 3 over pi. Pi's are gone. 6. Period is 6. Well, we knew that. One revolution takes 6 minutes. So this equation tells us everything we need. But they want to know how much time is spent higher than 13 meters. Well, so here's 13, and so it's from here to here. So I'm looking for this time and this time when it's above 13 feet. So what I could do is take this 13 feet, that's how high we are here and here, and that's going to equal 12 minus 10 cosine pi over 3t. If I subtract 12 from both sides, this will be 1. If I divide both sides by -10, I'll have -1/10 equals cosine of pi over 3t. Now if I treat this box as the angle, I'm looking for an angle, the box, that has a cosine value of -1/10. So like I did before, if I'm looking for the angle, it's inverse or second cosine of -0.1, enter. And that's this first time right here, 1.671. This other one, if we think about our circle, remember, cosine is negative here and here. So I know this angle. How do I get this angle? Well, isn't that 2 pi? And I can back up that angle I just found. So if I do 2 second pi, subtract the angle I just found, that's my answer, second answer, and enter. And this one right here is 4.612. So if they want to find the time that it's above here, I can take these two times and subtract them. The 4.62 is already here, so let's just do subtract, and I'll take that recent answer minus, and then 1.671, enter, and that's the time that it was. That's 2 minutes and something, right? 2 point. So 2.941 minutes. If they want minutes and seconds, well, that's 2 minutes. And 0.941 of the next minute, well, can I take 0.941 times, the next minute is 60 seconds, so it's part of the 60 seconds, and that's 56, let's say 0.5 seconds, almost 3 minutes.